So what is a photodiode array spectrometer? A photodiode array spectrometer records the entire spectrum at once, rather than scanning for a spectrum one wavelength at a time. A typical photodiode array spectrometer responds to visible and UV radiation.
A diode array consists of a number of photosensitive diodes placed side by side and insulated from one another in the form of a multi-layer sandwich. Diode arrays can contain up to 1,024 individual diodes in a row. Each diode may only be a few thousandths of an inch thick, and the output from each diode can be scanned and the data stored for a variety of different uses.
The mechanism behind the photodiode array spectrometer. First, white light, which includes all wavelengths, reflects off the elliptical mirror to the sample. Then it passes through the slit and reflects off another mirror. The beam of light is then directed to the polychromator. Light is then dispersed into its component wavelengths and directed to the diode array, where information is recorded and stored. Note that a different wavelength band will strike each diode. The most common use of a photodiode array is to monitor light that has passed through a liquid sensor cell, as in a multi-wavelength liquid chromatography detector.
Those wavelengths most useful in liquid chromatography range from about 210 nanometers to 330 nanometers, i.e. UV light, and thus a sufficient number of diodes must be incorporated in the array to at least cover this range of wavelengths. The advantages of the photodiode array spectrometer are that the speed is about 1 second per spectrum. It has excellent wavelength repeatability because the grating does not rotate. Simultaneous measurements at multiple wavelengths can be done, and it is relatively insensitive to errors from stray light. As was said, one of the advantages is simultaneous absorbance measurements at multiple wavelengths, not just for one wavelength at a time. When looking at a readout, you have the absorbance on the y-axis and the wavelength for those that are available on the x-axis.
One of the disadvantages of the photodiode array spectrometer is relatively poor resolution, from 1 to 3 nanometers.